See Lindelof videos applying Rolle's theorem, and the question usually is, does Rolle's theorem apply to this problem? So it's really pretty easy, pretty straightforward. All you're going to do is this. Remember that what Rolle says is that on this interval where that's continuous and differentiable, that if this is true, if f of a is equal to f of b, then there's at least one place there that the slope of the function is 0. So I'm just going to test Rolle's theorem out here. I'm going to say, does f of negative 1 equal f of 3? And f of negative 1 is equal to 0, and f of 3 is equal to 0. I'm just plugging in the value up here. So yes, it's true. So this is what your AP reader wants to see. They want to see you say that Rolle's applies. I want you to really try to hear me on this. If Rolle's does not apply, you need to say that. You need to say Rolle's does not apply, and then you stop. If Rolle's does not apply, you stop your procedure, right? You stop pursuing this thing. But here, Rolle's does apply, so I'm going to start doing that. So what it says is that we know that somewhere that the first derivative is equal to 0. So we're going to have to take this first derivative. So I'm going to set this up. This is going to be a quotient rule problem, isn't it? And we're going to have f of x is equal to x squared minus 2x minus 3. F prime at x will equal 2x minus 2, right? G of x is equal to x plus 2. Hopefully you're following this because this is just simple quotient rule stuff, right? I'm just breaking this piece up. Then I'm going to fit this into the quotient rule, and I'm going to say that f prime at x is equal to x plus 2, right? Which was g of x times f prime at x, which is 2x minus 2, right? Minus x squared minus 2x minus 3. That's f of x times f prime at x, all over g of x squared, x plus 2 squared. I'm going to clean up this algebra, and what I'm going to do is I'm going to go ahead and expand these two. I'm going to multiply these two out, and then I'm going to gather up my like pieces. And when I did, I got this, and it really, really made me mad, but I got this. When I finished cleaning that up, I got x squared plus 4x minus 1 over x plus 2 squared. So if you clean all this crap up and gather like terms, you'll get this. So I looked at this, and I started trying to factor, and I realized very quickly that this thing does not factor well. But I know this thing goes to 0 because I tested it for Rolle's, and Rolle's applies. So I know it does go to 0 somehow. So what I finally did was I used, and you're going to have to know how to use this, I used the quadratic formula. Another way that you could have done this is completing the square, but be aware that you are going to have to use some algebra skills on the exam. It's not all just going to come to you. And I hear you right now, so I'll just use my calculator. Remember that there are 4 sections: free response calculator, free response no calculator, multiple choice calculator, multiple choice no calculator. So while I get what you're saying about using your calculator, you will not have it for the whole exam. And where you're most likely to see this is where you don't have a calculator. Anyway, I used the quadratic formula. It can end up looking like x is equal to, let me do this, x is equal to negative 4 plus or minus, what did I get here? Plus or minus 2 square roots of 5 all over 2. I simplified this to be x is equal to negative 2 plus or minus square root 5, and hopefully you can see all that math. My points here are these. 1, try and see if Rolle's applies. If Rolle's applies, then proceed. If it doesn't, stop. If Rolle's does not apply, you stop, and you just write Rolle's does not apply, underline the word not twice, and don't move forward. There's nothing to chase. If it does apply, then you remember that Rolle's is talking about finding a slope of 0. You take your first derivative, you set it equal to 0, and then you solve for where that function equals 0. And you get your answers. If you look here, though, you'll see somebody hopefully is saying, hey, Charlie, remember that this function is not defined at x is equal to negative 2. And you're right. The reason that I don't care about this is because look at the domain. -2 doesn't occur in there, so I don't have to mention it. All right? Hey, you guys, I hope this video is helpful. If you have any questions or comments, please let me hear from you. And if you haven't subscribed, please do.